Welcome back. So today, we're jumping into one of the biggest shifts in all of technology. We're talking about the incredible leap from building computers that just, follow orders to creating machines that can actually learn all on their own. And believe me, this isn't just a tiny little step. It's the huge, fundamental change that brought us out of the world of rigid programming and right to the dawn of modern AI. So let's just start with the biggest challenge of all, right? How in the world do you teach a machine something as, well, human as common sense? I mean, just try to imagine writing a rule for every single thing the real world could throw at a computer. Every new piece of internet slang, every crazy turn in the stock market, every sarcastic comment someone types. You'd literally be writing rules forever. And it's that sheer impossibility that really sparked a revolution. You see, for decades, our best attempt at making smart systems was based on what we call rule-based logic. And the easiest way to think about this is to picture a gigantic, complex decision tree. Every single branch, every outcome, it was all carefully planned out and hand-coded by human experts. And it all boiled down to one really simple command. If this happens, then do that. Now, there was a huge strength to this old way of doing things, and that was total transparency. I mean, think about it. If a bank's system flagged one of your transactions, they could trace that decision all the way back to the exact line of code, the specific rule that a person wrote. It makes sense, you can audit it, and for stable, predictable things like a factory assembly line or basic financial checks, it actually worked really, really well. But that's the catch, isn't it? It only worked in those neat, tidy, predictable environments. The moment the messy, chaotic, unpredictable real world got involved, well, those rules didn't just bend. They completely shattered. And this image just captures the problem perfectly. The real world simply does not sit still. Fraudsters are always coming up with clever new scams that don't fit any of the old rules. Customers start using your products in ways you never, ever expected. A new meme goes viral, and suddenly your content filter is totally useless. And if you try to fix it by just adding more and more and more rules, the whole thing becomes a fragile house of cards. Change one tiny rule over here, and you might accidentally break 100 other things over there. It's a nightmare to maintain. And this is where everything changes. The big, game-changing idea. What if, instead of trying to spoon-feed the computer a rule for every possible situation, what if we just showed it thousands of real-world examples and let it figure out the patterns for itself? This, right here, is the birth of machine learning. So the most important thing to grasp here is how our job completely changes. With the old rule-based systems, we were the architects, drawing up every single blueprint. But with machine learning, we kind of become librarians. We're not writing the books anymore. Our job is to collect and organize the best, most complete library of examples, the data, and then we let the algorithm read everything and come to its own conclusions about how the world works. Let's use an analogy to make this super clear. The old rule-based approach is like a parent giving a child a very strict list of instructions for crossing the street. Rule number 1, look left. Rule number 2, look right. Rule number 3, if the light is green, and only if it's green, you can walk. It's precise, sure, but it can't possibly cover every weird situation, like a distracted driver running a red light. But machine learning, that's like the same parent taking their child to a dozen different intersections, busy ones, quiet ones, ones with bike lanes. The child isn't just memorizing a list of rules. No, they're building a deep, flexible intuition about traffic, about context, about what safety actually feels like. They learn that a ball rolling into the street might mean a kid is about to chase it, a kind of subtle pattern that no simple rulebook could ever capture. Okay, so let's get into the weeds a bit because learning isn't just one single thing. When we talk about machine learning, we're really talking about a few different approaches. You can think of them as the 3 main flavors for how a machine can learn from data. So first up is supervised learning. This is basically learning with an answer key. The supervision part, that comes from us. We do all the hard work up front by carefully labeling a huge amount of data. We feed the machine thousands of emails already marked as spam or not spam, or millions of photos labeled cat or dog. Then the machine's job is to figure out the hidden patterns so that later it can make really accurate predictions on new data it has never seen before. Next, you have unsupervised learning. Now, this is the pure detective work of AI. We just give the algorithm a giant, messy pile of data with absolutely no labels, no hints, nothing. We basically just say, go find something interesting in here. It's like a detective sifting through piles of evidence without any suspects, just looking for connections. And this is so powerful for things like discovering hidden customer groups you never knew existed or spotting weird network activity that might be a brand new type of cyber attack. And finally, there's reinforcement learning. This is all about learning by doing, just relentless trial and error. We create a software agent and drop it into a virtual world with a goal. Think of an AI learning to play a video game. Every time it makes a good move, it gets some points, a reward. Every time it makes a bad move, it loses points, a penalty. It might fail millions of times, but eventually, by trying to get the highest score possible, it teaches itself how to master the game, without a single human-written rule telling it how. So you have to ask, why was this shift from rigid rules to flexible learning so massive? Why was it such a game changer? What did it unlock that was just impossible before? It all comes down to one word: adaptability. A rule-based system is frozen in time. It only knows what its creators knew the day they built it. But a machine learning model, well, it's dynamic. You could almost say it's alive. As the world changes and new data comes pouring in, you can retrain the model. Its internal rules can evolve all by themselves. It learns to spot the newest scams, understand the latest trends, and adapt to a world that never, ever stops changing. And that changes everything. And really, that power to adapt is at the heart of this whole foundational shift in computing. Thank you so much for joining me today for this explainer. Knowledge Equity Partners is a multilingual channel where we share contemporary and practical knowledge on a variety of topics that can enhance your daily lives to make it more effective and efficient. If you find our content valuable, please subscribe to Knowledge Equity Partners so you'll get notified about our daily videos. Don't forget to like, share, and spread this valuable practical knowledge with your family, friends, and community. Let's together keep the quest for knowledge always high. So we've seen how we went from fixed, rigid rules to algorithms that can actually learn from experience. But that begs the next question, doesn't it? How did we get from these basic learning styles to the incredibly powerful AIs we see today? The ones that can translate languages instantly or create unbelievable art from just a sentence? Well, in our next explainer, we're going to bridge that gap and dive into the evolution of neural networks. You won't want to miss it. See you then.